Already done some work with a couple of cookers and a hob, and we've already chased down this stuff. But what we're doing today is getting this cooker hood into place. We're going to put it in on, we'll just strip that out. That's going to run up into the ceiling, and as you can see, we've already got that chased out all the way down there. That's the ring. That's on the ring, which has all been done up in the loft already, and we are just about to put on fuse spare. It's already down rated to 3 amps, which is what the cooker hood requires. So we're going to run an extra piece of 2.5 there, and then we're going to run a 1.5 up that chase into the loft and connect that onto there with that. So we're going to do that, get all that lot done, then that gets that up and working, and then try and work out all the lights. Alright, so we're going to throw that up through there. Shove that up through that hole, well, it will be a hole in a minute, and then run that 1 point. We don't need a 2.5 for this because it's only a 3 amp hood, so we can run the 1.5. Run the 1.5 down there and down there on the ring, and just tee it off there. And that'll be absolutely fine. Always get a unique problem on one of these jobs. But yeah, so doing it this way because we thought we could just plug it in, because I've actually had to cut the plug off this. I thought, no, we're doing a new kitchen, so let's do it neatly. And this cable will be covered by the cowling anyway. So, oh, there's an RCBO to go on this circuit as well, which I'll do. That's on order. That'll be here tomorrow, so we can put the RCBO on this circuit, and then that's done as well. And then there's a garage socket that's got to come off the ring on its own radial on a 20 amp, so we'll do that as well. Okay, so that's the white cable up into the loft, and here we've got the all the way down here, and then we've got the 1.5, which we're going to terminate into that fuse spare, which will then control that hob hood. Okay, so the hob is there. Yeah, that's all been disconnected for the time being. The connection unit's there, the switch for that is there. Switch for the cooker, which is in this bit here, and there's the connection unit for that. Both these on 4mm, because they didn't need to be on anything else. They're more than adequate to be on 4mm, both of these. They're on separate circuits. As you can hear, the owner's working upstairs, so the owner's doing a lot of the building work and I'm just doing the electrics. Excuse me. Right, so there we go. So that's those cables where they're supposed to be. They'll get all pulled up and nicely. We've got some capping to go on this, so that'll do that. So I'll just get all these wired together. I won't wire that bit into the ring just yet, because I want it I'll wire that up later on. I'll just get this fuse connection unit wired up, and then I've got to connect the flex to that in its junction box. I'll do that next. Right, hopefully this is actually showing this, so I'll just quickly show how I was taught to strip back to the earth. So, crumbs. So, tap that to there. Just pull that back slightly. And that, pull that up. And then just get the pliers use the earth wire to pull it all the way back to there. Pull the sheathing back, and then whoops, get the clippers. That's done, and then we'll just get some earth sleeving to go on that, 3mm. Just get this one. That. Don't know whether that showed that on the camera then. And pull that back. Oh, like that. Pull back the sheath. And clip it off. Right, so we've got all the socket fronts back on. We'll just check them. It's working fine. Switch on the fuse spur. Come over to here. One finger. It's all working. Get the lights. One and off. Oh, and the light off. Okay. So what I need to do is just make that nice and tidy through there. I need to mount the junction box on the rafters and get the conduit put in, and yeah, then that can be the owner's going to do a lot of the building work, so the owner's going to put the capping on and then get the cupboards back on, and then while he's doing that I'll get the wiring tidied up in the loft. But yeah, I'm pleased with that. That's come out really well. This kitchen's been going on for a while. Like I say, I've done all the electrics in here, so all the electrics all done to my standard. Admittedly, the owner did those two lights. He wants me to check them that they've been done right, but I've got to do those three down there. So I've got to wire those up. So I've got to put in another 1.5mm cable. I've got to tap off all this stuff. So put in the under cupboard lights, which we've got to get. That should be the next job. But yeah, so that's sorted. Multi-tool did the chasing. Love the multi-tool that I've got to do that. But yeah, so that's it with the hood. So the hood's done, the cooker's done, the hob's done. This circuit needs an RCBO putting in, which I'm probably going to do next. So we've got to fit an RCBO to this. In fact, we're going to fit three in the end. One for a cooker, one for a hob, and one for the garage. That's the cooker line, which we've fed over to the cooker, over to the kitchen side. So that's all been tested, and continuity and installation resistance, that's all been done on that line, and it's all been fed through, so that's been done. So this is the next part of the job, is putting the cooker circuit RCBO in. Just switch that round, and we're going to be replacing this one and moving them all down, because we've got a couple to put in. One for the cooker, one for the hob, and also one for the garage, at least to start with anyway. So yeah, so we'll get on with that. Right, so here we are with the new RCBO in place. New tails in, well, the new 4mm cables. Cable in for the RCBO. There's a lot more work to be done in this, that's why I'll tidy up all that wiring. Make it neater once all the wiring's done. There's a couple more circuits to go on this board. I have underneath, the bus bar's not long enough, so you can fit a longer bus bar, so we can get another 2 circuit breakers in there. But that's all in. We've even now run the new cable for the hob. We've just tested the cooker out. The cooker works fine. All the RCD tests have passed. So yeah, I'm happy with that. So we're going to put in an RCBO for the ring final that we've done in the kitchen, which you saw earlier on, and there's also going to be an RCBO for the kitchen lighting circuits, which is the one that's currently off. Yeah. Now the actual installation isn't actually in that bad a state. I did a check on this, like I say, right back at the beginning of the year. The only issue I've got at the moment is right down the back there is an RCD socket. Now that could interfere with the RCBO I'm about to put in, because it's actually hooked off the ring, that one. So I might have to disconnect that one for the time being. I might have to try and work that one out, but we'll work that out later. Anyway, so that's what we're doing this morning. So we'll do an RCBO on there, RCBO on there, and I'll show you how they test. One thing, I've got a call out to find out how you do an RCBO test on a lighting circuit, because you can't actually plug the tester into anything. So I'm just going to try and work out how you do that, but once I find out, I'll show you how we do it. Okay, so here we are with the cover off. Now, as you can see, we don't actually have a lot of room to work with in here. But as you can see, so these RCBOs have the line, the neutral, the line and the neutral, and then they have their fly lead into here. They don't have the white fly lead like the old big RCDs, by the way. Let's turn that off. No, we don't need that one. That's better. So as you can see, we've got mixed wiring in here, which is hence the reason for the labels. So we've got all this black wiring, which I'm going to have to manoeuvre around. You can see on the ring final, it's got 3 cables. That one of those cables is heading off to that garage socket that I said is an RCD socket, and I'm really concerned that could interfere with the function of this RCBO. I seem to recall when I did the RCD test on that, because it's the only RCD here, it didn't work. So I'm not sure, until I do it, I'm not sure. Now, as we can see on the lighting circuits, we've got 2 into that one, 2 into that one. This is the one, that's the kitchen, which is the one we're going to replace. So we're replacing that one, and we're replacing this one. That's the immersion heater, we're not worried about that. This is the other lighting circuit. So there's 4 lighting circuits actually in this house. 2 there and 2 there, so these are the 2 we're going to play with today, and we're just doing that as well. This is what I'm going to do first. I've tested it's all dead. I'm not going to lock it off because I'm the only one here. The actual owner's now gone for a couple of hours while I'm doing this, so I'm the only one here, so I'm not going to lock it off because no one's going to be here to turn it back on again except me. Anyway, just very quickly, as you can see, I've actually managed to identify some of the cables running up there. As I say, it isn't actually in a bad state. I'm not overly concerned with the state of the wiring in this property. It's quite an old property, it's a bungalow. But obviously I'm really tight on space in this board, as you can see. How I'm going to address this nicely, I'll be honest, I'm not sure. I really don't have a lot to work with in there. Anyway, we'll see what we can do. Ah, yes, I remember now. I thought this thing it does have slots for spare ways, but as you can see, the bus bar isn't long enough, so I couldn't put more circuit breakers on there, even if I'd wanted to. Anyway, there's no isolator switch, so we couldn't do much with that anyway. By the way, it's a TNS system, people. Anyway, let's get this job done, and then we can get on with what we're doing upstairs. Right, as you can see, we really don't have a lot to work with in here. I would love to just strip this and redo it from scratch, but I can't because I can't isolate the power, not without taking the fuse out, which I'm not allowed to do. So I'm going to have to work with what I've got. So apologies for all those out there who's going to say this is a mess. Well, it's going to have to be for the time being, I'm afraid. It's a really tiny box. I'm trying my best to try and sort it out, but realistically it needs to be totally taken apart and put back together again. Okay, right, so we've got those 2 RCBOs they're in. I've made a pretty good job of that bit there and along there, but as you can see the mess behind is, I just can't do anything about that, unfortunately. So I'll just try and make good as I can, try and make it at least as neat as possible as I can. I'd love to do that better than that, really. Okay, so we're all wired up, as you can see, but I will tidy up a little bit before I put the cover back on. So we've got the power on now. I've got the power onto the RCD for the ring final. The 2 to the right of it are for the hob and the cooker, which I've disconnected, so I'm not leaving those off. The immersion heater's off. The lighting circuit one is off, and the other lighting circuit is currently off. So we're going to go indoors and we're going to test this RCD. So let's go and hook it up. Actually, no, we're not. I'm going to put the cover on because I'm going to leave this unattended now. So yeah, I'm going to put the cover back on and then we'll do the RCD tests. So here we are. We've just got it all connected up. My test kit. So we've got the tester in the live settings on here. So we've got line, CPC and neutral in the live test settings. So we're going to set this to 30 milliamp auto. Just about to see that. And set the test button going. Oh, well, yeah, helps if I turn the power on. Wouldn't work otherwise. You can see it's saying 247 volt, 248 volts, so we know it's working. So off we go with the tests. Pass on the first one, half. Pass on the second. .6 on that, so
your kids are you in the rain, mate?
Oh no, I just to shut it all off.
Well, you want a coffee again? Do you want sugar in that or?
No, that's fine.
Right,
that'd be right. Thank you.
Shall I leave it here for you?
Yeah, thanks a lot.
Are you working out here or are you inside?
I'm in and out at the moment because I'm doing the RCD tests.
All right, so you've got.
I'm just doing this now.
In, yeah.
Yeah, so I'm just flicking on and off now. Should do it a couple of times. So you're making notes this year. So if I go to that, should be pass, yep, 7.6.
So what's that?
16, 10.8 and 15.6. Okay. How to test an RCBO on a lighting circuit. So what I've got here, I've got the QTech lighting adapters. So that's a bayonet one that's in there at the moment. So as you can see, we've got the line, the neutral into that, and you can see the earth is crop clipped to the earth bar at the pendant. Now QTech do lots of adapters. They do GU10s and E27s and so on, so you should be able to find one that will fit. So what we have here is we've got that all connected up there. It is live. I'll just bring this down here. You can see there it is live. This is the only way that I know of to do it. Obviously you've got to take great care in doing this because obviously that is now live. That, however, it does work. So as I say, we've got all those leads on. They're connected into the line, CPC and neutral on the tester, and you can see we've got a voltage 249 volts. So press the on 30 milliamp auto. So let's start the test, and we've passed. Don't forget this is on our new RCBO that we've connected into the lighting circuit. Passed again. Go to the next one. There we go, 7.6, so let's go and sit by the consumer unit. So here we are, kitchen lights. Let's turn that back on. Second, another test done. Do it again. And another one. Do it again. Yeah, and whoops, and again. I think that's the last one. Let's go back to the board. Hopefully you should get some nice figures, I hope. Let's see what we've got. So we should have, whoops, 2000, 7.6, 18.4, 7.6 and 18, all passed. Just to say, this is the lighting kit that you can get from Q-Tech. So as you can see, we've got screw versions, bayonet versions, that's GU10 version, and hang on, that's one of those. So they've another bayonet one. So you've got two bayonet ones in the kit, two screw fittings, and a GU10. The only thing is, some of them are labelled line and neutral, some of them are. You'll know when you get it around the one way because the tester won't work. Anyway, so that's that. So that is coming really handy to do the RCD test, and it will probably come in handy when I have to do the R1, R2 test when I've cabled up the rest of these lights. Okay, where are we? So, got three lights to do. This one there, you can about see it, and there's one over there. And the pendant light is somewhere around here. So we've got the lines coming up here. So I'm going to disconnect the pendant light, pull out the wiring. I think that's the best thing to do with that. These three are going to be independently switched. So get that wiring out, and then I'll use the quick connects, I think. Yeah, I don't think I'll daisy chain these together. I think I'll do it through the quick connect, I think. And mount it somewhere in this, somewhere around here. The other lights are down there. Yeah, so the switch line should be here and the mains line should be here. So if we put the quick connect in, power line in, switch line in from the switch, and then there should be two load lines coming out. We can use one load to another quick connect, which would have three out, which will be the three that we can connect to these three lights. That'll keep the runs nice and short and hopefully quite tidy. So I'll do these three, disconnect, get rid of that pendant light, connect all these lot up, then back to that, those two, redo the junction box on that, run the cable out to the cabinet lights. We've got the 1.5mm cable here, that's hooked up in the ceiling. It's not live yet, we'll do that in a minute. And we have all this LED equipment from LED Space. So we've got a RF LED driver, that's a 75 watt version. So you've got the 1.5 cable going into there. Now at the other side, whoopsie daisy, that can all be hooked up to single colour, bi-colour and RGB. If it's RGB it's one channel, if it's single colour it's 4 channels, so we can run 4 separate circuits off that if we need to. We are going to run two, in fact. We're going to run one on this corner unit here, and then a second circuit will be there, which leaves us two. We want to run any other circuits at a later date, which is fine. So we've also got 24 volt LED strip. There's 3 meters of that. We've got this, you might be able to see on the label on that cable, it's 2 by 0.75mm flat cable to connect it all up. And somewhere we've actually got an RF dimmer switch, which just sits on the tabletop, that's powered by a, I've lost it, there it is, just powered by a standard watch or smoke alarm type battery that's in the back of that. So what we're going to do at the moment, we're going to test out, make sure this LED strip is all working. Usual Christmas light fashion, make sure no dead LED spots on it. So we'll hook that up into the driver, and the driver will sit on top of the cabinets, run down the back of the cabinets with the white cable, hook them up. We've actually got, I've lost them, there we are, we've got these clips, which one end clips onto the LED strip, one end clips onto that white cable, so we've got those to make it nice and easy. And up in the loft I'm going to hook up that twin and earth into the main circuit using those quick connects, which I've got. Again, I've put down some and I've lost them. I'll put them down somewhere, they're around here somewhere. There they are. There should be one left in here. Yep, there it is. So we'll hook that up in the loft, and that'll be, we'll liven that up, and then we'll pair that dimmer switch to this driver, and in here, just about see it's right down the back there, there's the button to match it with. So we'll do that. So yeah, so that's what make is that, that's a Skydance. You can just about see the model number on there. So yes, we'll hook that all up, get it tested. The aluminium extrusions are coming this morning in two 2-meter lengths with all the end caps and stuff, so we'll get those in and then we'll cut them to length, and then basically this strip sticks inside those extrusions, and then there's covers to go on top of it, diffusers to go on the top, which hopefully, if the advertising holds up and what I've seen, will mean it won't look like there's individual LEDs, it'll look like just one solid light. So we'll get on with that, we'll get these cables put down the back of there and stripped, and we'll see if it all works. What we've got here, we've got all these, get those clamps out of the way. Got this clamp which we're going to put on, just to show that's been done in there. Oops, there we go, that's in there. We're using one channel at the moment, the matching switch is over there, so we're getting that down on there now. The only downside with this was that the clamping bar is missing there for that cable, but with that closed, and being that this is a 24 volt cable, I'm not overly concerned about that, to be honest. That's, as you see, that lid's going to close down quite tightly on that anyway. So anyway, just a thing. So this needs to be clamped on, so it works that way round. So that clamps onto the LED strip, that end clamps onto the cable. If you can just about see, if this will focus, it's like connecting data cables. So those, you need to strip the outer sheath obviously, but you don't need to strip the inner sheath cables, and then it all clamps down. So that bit clamps down. If I just bring the LED strip up, I'm testing the LED strips, and nothing's been cut to length yet, so I'm just testing to make sure everything works. So you can see you cut on those bits there, and then it clamps onto those. So we'll get that all clamped up, then that bit's done down here, and then I'll go up into the loft and we'll get the power off to the lighting circuit and get this clamped in and then matched up, and then hopefully it all works. And if it all works, great, then we can start getting the cables to the right length. Okay, so here we are back in the loft, so that's the cable going down to the cabinet lights rather, sorry. Here's the one we did the other day. So I've just cut into the lighting circuit there. That's like that's going down to the that's going down to the lounge light and then back to the board. So we've just intercepted that, and we're going to hook up that into those three. I'm just trying to get the cabinet lights up to working at the moment, so we might have to increase the length of that to give us the more space that we need. So yeah, but well, let's get these powered up, and then we can tidy up here in a minute. Right, so we're all hooked up now. As you can see, we've got a nice red light on the transformer all the way down to the cabling, so we can test out the lights. This connector is nice, but it is a bit of a faff. You have to make sure you clamp down this side with a pair of pliers to make sure you break through the insulation. The first time we tried this we didn't, and nothing happened. So we tested to make sure we had 24 volts coming through there, and this actually paired up successfully, which it had. So to pair it, you have to press that button there and that will flash, and then you press this button and it will pair up, which it has. As you can see, we're all lit up. This is a dimmable control panel. You can either rotate it to dim, up or down, or you can press and hold. It goes up, press and hold again. It goes down, press and hold. Let's bring it up a bit. Short press and short press, it all works. It's a nice little desktop unit that can go anywhere. It's all RF controlled into this driver. As you can see, we've got another, this can have a 4 channel, so we can actually put in another 3 cables into there, into this particular transformer. It's 75 watts, it's more than enough for what we need. Okay, one lucky thing about this is we'll be able to take the covers off, so we'll be able to route the cable nicely along here with these sticky strips and sticky clips, which are really nice, and it's come really nice and flush. You can see these are the support beams for the cupboards, and they're below that level, so the cupboards are going to go up really nice. So we'll be able to run the cable all the way down here and out to where it will actually connect up with the lights. So a little bit of an advantage there, otherwise we'll just have to have dropped them down beyond the cupboards, but no, I like that. So we've got the cable here, which is coming down. No, it's not in focus. There we go. So we've got the cable here coming down from the loft. As you can see, it's over there. It's not plugged in yet, so it's not live. Now, this isn't quite long enough to go with what we want to do. So what we're going to do is we're going to stick that in that Wago box. So stick it in there. We'll just stick a couple of connectors on, and I've bought some new cable there, which we're going to use to come down the side of the cabinet. It might come down the side of the cabinet, so it might come down that side, I think. I'll come down the ladder, and we'll do Blue Peter style. We've actually got the first of the tracks installed, just to make sure it's all in place. So this comes in 2 or 3 metre lengths from Ultra. The profiles come from Ultra LED, and all the rest of I will remember the manufacturer of the other equipment that actually that you saw the other day. But I've had to go with profiles from Ultra LED to make this all work. All over the place with the video this time. So I will go through how that's all been mounted up when we do the other cupboards. I am not going to use the quick connects, the clip connects for this. I think I'm going to directly solder the LED strip inside. So I'll just show you what we're doing over here. So here, obviously, strip that cable back. That's an end piece to one of these profiles, and we've got 2 cables coming through, and there's some heat shrink over the top. So what I'm going to do is heat shrink that down there, make it nice and short as possible, so it just protects the wires, so there's no protruding wires out the side. Clip these back, and then I'm going to solder these directly to the LED strip inside. I just think it's going to look better. I think we can get the LED strip right to the edges then, rather than using those. It was a good idea, but I just don't think it's going to work. So, as I say, I'm going to solder those into place, so that'll be fine. As you can see, we've got it all connected. That's the strip which I'm going to be using over there. So that's all connected into that one at the moment, only because I've got the lighting circuit working. It's 24 volts, but just to be safe. Right, so hook up those cables up there, run them down the hook the cables up there, run them down behind the cupboard, and I'll put them into that so it's all done, and then we'll get it soldered up later. Okay, so there we are, that's all hooked in, a couple of Wago connectors in there, and I've ferruled that end of the cable because it was stranded, so I put some ferrules on that, 0.75 ferrules. That cable's now running down there, and got the right length, and runs into the end of that light fitting, so that bit's done. Okay, so I'll just take you through this. This is what you get from Ultra LED, based out of Trafford. So you get 2 metre lengths of this aluminium. This one is one of their smaller sizes. It's reasonably easy to cut. I've got a engineering hacksaw. There we go. So you will get that. You will then get, they do various tops. Now this is one of their pearl ones. You can get solid clear ones, all different types from them. And again, that's cut and then clipped into place on there. And then you can also buy the clips that are attached to the base of the cabinets, which I'll show you in a minute. And then there's end pieces to go blank to go on that end, maybe another end has a hole which 2.7mm cables, conductors will go through. So yeah, so it's ideal for this. The tape that's going in there, the LED strip tape, I believe is 8mm, so it will fit nicely in there. I think if you're doing RGBs, or say 10 or 12, this probably wouldn't do it. You probably need the bigger one. Anyway, we'll get this cut with that engineering hacksaw, and then we'll go from there. Right, just a quick one, just cut through there. What would make this much easier would be a mitre box, and I do have one, it's just I forgot to bring it with me today. That would make sure you get a nice straight cut right the way through. So just a bit of a tip there. Okay, just very quickly, we've laid that diffuser on the top. Those are the clips, by the way. Small screw going to that. I'll show you how to do that in a second. So the diffuser I've just clipped into place all the way along, and then what I'm going to use is my side clippers to cut that to length, and then I know that that's a nice accurate cut. Whoops, there we go. Really did not want to focus today. Put my foot out of the way. There you go. So there you go, that's all nicely cut to size. This length probably will need to be cut further. It depends. When we actually fit it to the cabinet, we might find that this has to be a little bit shorter, but at this length at least it's more manageable. We can get more precise measurements when this goes up then. It's lovely and cheap, this stuff, so it's not a problem, but with a bit of wastage, to be honest. So yeah, so I'm pleased so far with this. This is going really well. So okay, so we have excuse the mess. So we've got these 2 strips now cut correctly to the correct length. So you can see the actual LED strips all cut to the right length, not attached in. And we're going to be putting them under here. Oops, let's go back a bit. As you can see, this is like angled cupboard, so we're going to go a straight piece down there and a straight piece along there, and then we'll connect it with a piece of cable between the two there. So that should do that. So we're going to mount some clips. I've marked them up. You probably can't see them. I've marked them up. They are marked up. Going to get my drill just to break the surface, because it just makes it easier when you've done that. And a couple of clips on there. I'll probably put one, couple there, and a couple on that length should do the job. By the way, the brackets I'm putting up, I've obviously used fairly small screws to avoid penetrating the cabinet, so about that long. Now I've just checked the measurements on this, and they're actually where are they? One sec. The smallest screws I've got in my packet, they're 3.5 L16, so 3.5 diameter, length 16mm, and they work really well with the brackets that I've been given, so they're not going to come straight through. The next size up could have actually come through straight through that. So just a bit of information there. Okay, just very quick. So I've drilled a pilot hole just to break the laminate surface, makes it easy to drill. So chosen the smallest drill I could possibly find, which I think that's a 2.5 actually, I think that drill. You don't need to drill too far in, just far enough to break the laminate, and then it makes it easy to screw. Right, just to make sure that everything is working as it should be, I've temporarily connected it up to the main power cable for this particular strip. So that strip is all there. As you can remember from earlier on, it's remotely dimmable. Let's just dim that down. There we go. Now, yes, you can see the individual LEDs there, but that's because it's not been attached inside that profile, and you can see where it's. So that spotting won't be there when it's attached to the back of the profile. So that's not. I'm not too worried about that. But it's nice and bright. If we come away from there and just come to there, we'll just turn it up. So it's got a nice bright light going down the end of there. As you can see, it's all the way along because I've only done it temporarily, just to make sure that it's all working fine. So we'll run a cable between those two there. I'll put another support up on the end of that one, and then I'll cable those together. These, as I say, we're going to solder the ends of these on, and yeah, I think that's looking quite good. Yeah, happy with that. Okay, so we have a solution to our lighting thing now. Got those connectors, so if I just take that off there, there we go. So 24 volt connectors snap fit onto the end. That's been soldered onto the end of that strip. All that does is that connects into there. As you can see, it's snap fit onto the cable coming down, and that enables us to remove the lights if we want to. So I'll carry on soldering the rest of this cable. Unfortunately, the original cable had a fault in it, that's why it's a different cable, different light strip. So just plug those in together, nice and neat. Right, so those connectors, the idea came from Model Railway, so they're 24 volt connectors. That's all nice and neatly that's clipped into place, and those lights can now be disconnected for maintenance if they need to be. So it goes all the way along there. 0.75mm cable used, I believe, from off the top of my head. And obviously we've now got that one working there as well, same barrel connectors. Obviously that cable goes up into the loft and then back into the driver that's on the top there. And we've still got 3 spare channels for other lights if we need to use them. Just to show a quick close up on these, as you can probably notice on those and on the bottom bit, I've used 0.75 ferrules to get those in. It just gets a nice neater connection on those barrel connectors. So 3 spotlights have already been put in, one there, one's disappeared down there, one's over there. We've taken out the pendant light, which was there. So we have identified all the cables. So the switch line is now that one. That's going off. Nope, wrong one. This is the switch line. Yeah, this is the switch line. I've actually labelled it up, but there you go. That's the switch line. As you can see, we're using the quick connect ones. I'll put together something else on how that all goes together separately, because that's not easy to do when you're holding a phone. But anyway, that's the cable going down to the switch. That's into the switch port on that. Then we've got the 2 power lines. That's the power going off. That's the power going off to there. Then it goes to an outside light, and then it carries on down behind me. This one heads off down there to the other kitchen lights, which are on a different switch. And then that heads back. We think that heads back to the consumer board that way. We believe. But anyway, so that's all connected up. Prove that all works by hooking up one of the lights. But what we're doing is, that's the end of this particular lighting circuit. So I've hooked that cable in. I've hooked that into there. It's a nice snap fit connectors on these lights, which is nice. Just to move that out of the way. Into there. I'm just going to loop another cable from that one over to that one, and then the load will then come back into this, leaving a lot of slack on the cables, because as you can see it's being built up. This will all be insulated down here, and then that's all going to be built up. Intermittent hoods are going to be put on these lights. There's 5 in total, 3 on this circuit, 2 on the other one. So that's what we're going to do. Like I say, I'll do a separate video on this clever little gadget that's saving a lot of time. But yeah, so that's what we're doing, just looping these in, and then we'll load that up, and then hopefully we'll be able to pair it up. Right, so just so I'll show you this, that's all nicely in. I do like these snap connectors. So that's all nicely in, so that just snaps down into place. Done. Nice and neat. Put that down, then we'll run that cable over to that one. There we go, so that's in. Turn that off a minute. There you go, so that's all into that last one. I'll just shut that cover up, and that one's done. And then that line, where'd it go? So that cable that I've just done, that one. I'm going to hook that up into the quick connect, which is sitting under there now. Right, so that's all these lights all hooked up. I know it looks like a dog's dinner, but there's a very good reason for this. We're getting all these wiring done, and then, like I say, the owner's boarding this all out, and all these cables are actually, he wants them all up on, they'll all be up here and out of the way, so I'm having to leave more cable than I would do normally on this, and everything, all the boxes and things will all be mounted properly, but that's for another day. We just want to get this wiring done, and then we'll get it all mounted properly. Okay, we're just coming over to these lights now. I've got to run an extra cable down for the kitchen lights. I need to intercept the power cable for this, but I just wanted to show you this. This isn't done right. Obviously there's no earth going to the lights, that's fine, but that's not right. You shouldn't have that like that. There should be a junction box there of some description. and here's the other one, and that's the cable's been damaged there. That's not really been done correctly either, so I'm going to rewire these correctly. They all go back to this junction box. That's the power feed cable that's going around the house. So I'm going to rewire those, get those correct. So what we're going to do now is we're going to actually replace that Wago box with another one of those. And then we'll loop these two lights together. And then that'll be it for today. I'm still waiting for the chin. Then we have, those are the two loads to the lights which I'm removing. The far left cable is the power cable going back over to some more lights and the consumer board, and that one, crikey, that one is going down to the switch. So I'll get that all redone and then we can go from there. Here we go, let's just run this through. So here's this light, we've got cable going to the second light over there. This is the load. That's running all along here, so we've got a quick connect. Fitted up. It's all set up to switch power and load. Had to fit a Wago box on this one because there isn't one of those black boxes there. So that's going into there. That's Wagoed into that, which is running over here. Running over there. Circuit all now put back together. Mounting the tray work in the loft today. I didn't want to do any videoing this until I was absolutely sure that this was going to work, and it is. So I'll show you the solution that we've come up with. So let's just put the tray up. So we've got two screws in already. So there's the first half of the tray, small tray going down there. So the tray's coming up to here, it's ending there. So I've cut this all off. This is all filed off nicely, and there's no sharp edges on there. But the I'm not using standoffs on this because it was going to stand off way too far. And these supports here are going to be supporting sheets of MDF. So we can't get too close. So this is about the height that we need to be. So they've been directly mounted onto these beams. So the screws I've found to do this, and they've worked really well, are these. So you might be able to see there's a clear plastic washer there, screw in the middle of the washer, and then there's a plastic cap that goes over the screw which protects the cable. So hang on, let's see if I can get right, so that's the cap that fits over the screw, and so there's the screw, and I'll just do, how do I do that? Bear with me, it's not easy with the phone. There we go. So there it is. So there's the thing. There we go. So if I just put that on the screen. So and that's what they are. And that's working really well. So I've got two up just to get that all nice and level. I'll put the MDF back in a second just to make sure it is. We've got some adjustment we can do with that if we need to bring it up and down. So we'll put another screw in there, and then we're going to put screws in on this beam here, two there, and two on that beam, and then it stops there because of that cable that's running up the wall, and then the tray will carry on past there. So we'll get on with finish mounting that in, making sure that's level. If it's level, I'll put the other screws in. Okay, that's the tray all installed all the way down. There's going to be another gap there because of that cable coming up, and all the way down there. So what we'll do next is we need to extend the ring final circuit, which is this wire here, which is very tight, going at a diagonal line all the way over there. So we're going to cut that, and I'm going to lay 4 meters of new cable into that tray to extend the ring final, because we can't have that so taut across out, that's ridiculous. So we're going to do that and then mount that in. So I will go and get the 2.5mm cable, get that mounted into the tray, and then we'll splice that in, and then we'll make all the lighting cable nice and neat. So we've mounted the new ring final cable. As you can see, we've used those I can't remember what they're called now, brackets. So it's all metal brackets. As you can see, this is all mounted up practically upside down. So it's all have to be suspended correctly. So it's all metal clips. It's all galvanised actually as well. For suspending the cable to avoid premature collapse. I'm trying to think of the words today. So that's all, that 2.5mm cable is all mounted into the tray, and you'll notice down here it's actually poking out through one of those slots. Now those slots are absolutely perfectly smooth, so there's no sharp edges there whatsoever, so there's no need for grommets. At least I wasn't putting a grommet in there anyway. So that's not going to cut that cable, not a chance. So I've left a little bit loose there, so it's poking out the back. That cable's going to be junctioned off to the ring final at that end, and as you can see, it's poking out that end as well. So yeah, so that's all perfectly done. So that's all mounted up, so I just need to get the junction boxes at both ends, splice that ring final, and then that's sorted. And then we can worry about how we're going to neatly do the lights. Okay, so we are done and sorted. So top cable, ring final, bottom cable is the lighting circuit running all the way down the back there. A couple of junction boxes running down to the lights, which are there. Plenty of slack on the cables for the new boarding to go in. Still some slack on the cables there. Junction boxes all attached and nice and neat. Again, like I say, we've got slack on the cables for the new boarding to go in. And like I say, slack on the cables down there, but at least it's now all out of the way, ready for the boards to go in. Okay, so it's commissioning day here at this job. There's still too much to do up in the loft just to tidy things up, but I might as well get the testing done now. So, going to test for the new lighting circuit. So, disconnected it's all powered off, all safely isolated. So these two cables here were also in that same one. They're going up to this. I'm not worried about that. So I've got the neutral on the line. Fortunately, none of those earth CPCs are in the right place, which I didn't realise. So I'm going to locate the right one. I believe I know which one it is, but we'll get the R1 R2 test done for the lighting circuit, which is a radial. So I've jumpered it in the loft because it's easier to do there, because there's downlights now. So I've jumpered the actual power cable upstairs at the end of the circuit. As I'm up there, I might as well do it. I know where the end of the cable is. So I've jumpered it up there, and I'm going to locate the earth CPC for this circuit, jumper it to the line, and we'll get a reading. Don't forget, null your leads before you're doing this, which is just done, which is 0.33, so on a Q-Tech. Is that. And those leads are now nulled. Now I can do my test. Okay, and there we are. That's the R1 R2 reading for that brand new lighting circuit. So we can leave that one alone now and get it all hooked back up again. Right, so we're going to do an insulation resistance test. So you can do it at the top of these RCBOs, as you can see. You can do an IR test there, but you've got to have the RCBO on. Now, I've just done the test and it's actually passed. It's greater than 2000. It was 17 mega ohms on when I did the line and earth, neutral to earth, but line to neutral was greater than 2000. So it's passed, but I just thought, because it's a bit difficult with my phone, I can't really show you the results. But that's how you would do an IR test with an RCBO, especially, well, at least on the Hager ones anyway. So you just need to make sure that your RCBO is on, and then you can do the test. So we're going to do the new ring final circuit that we've done. Now, because there's 3 cables that are into that, so I need to work out which is the spur. Okay, so we've got the those 2 are the ring, and that was the spur off the ring. Okay, so there's the lines. I've done the neutrals, and we're coming up with 0.7. Oops, finger in the way. 0.7 there on both of those. So I need to multiply that by 1.67, and my math is out the window to do the CPCs. I've got to find the CPCs in here. Okay, so my math is saying that it should be 1.17 for the CPC, and we're getting 1.19, so that's within tolerance. That's fine, so there's nothing wrong there. So now we need to cross connect the cables. Figure out the cables. That's what we need to do. So there's the figure 8 for the R1RN. As you might be able to see, it's a bit tricky to see really, but you can see that I've done the, well, there should be a cable that going there to there and there to there. I'm going to just double check, make sure I've got those on opposite cables, otherwise that won't give the right reading. Okay, in actual fact, I actually have got that round the wrong way, and you might be able to see that that's now round the right way now. So we'll go and test that and go from there. Should be getting a reading. It's 0.7 plus 0.7 divided by 4, which is about 0.35 is the reading we should be getting on there. Okay, so R1RN for the ring, 0.36 should be in 0.35, that's fine, that's within tolerance. Okay, just for completeness with this video, I've just done the insulation resistance test for this. Oh, let's turn that off, don't need that one. Again, having the RCBO on enables me to do the test from the top of the RCBO. I'm going to do the cooker and the hob, these are these 2. And then that's my commissioning complete for those circuits, and I can finish up in the loft. Just about, sorry. I didn't include in the video the test for the R1, R2 for the ring, because it's exactly the same procedure. It's just I just need to do a figure of 8 between the line and the CPCs, and that came out exactly as it should do. That should have been 0.7 and 0.12, I think it was. We did 1.9. Divide that by 2 is 0.9. No, sorry, divided by 4. What did I say it was? 0.7, 0.12, 0.1.9, divide that by 4 is about 5. Yeah, it was about 5, and I was getting about 0.48. So yeah, it's within tolerance, it's fine. And we'll do all we'll put it all on the paperwork, and obviously we've got the ZS and stuff that I've done all the ZS and IPF stuff already done. I did that the other day, so that's all been done anyway, so I don't need to worry about that. And we know this is a TNS system. There you go, TNS, just for your knowledge. So we know what we're supposed to be getting on the ZE, so anyway, so that's all been done. I've done that already. Okay, so the readings for the hob R1, R2 is 0.35, that's the 4mm cable. I'll check that, but I think that's absolutely fine. Right, can I just say very quickly, so today's the commissioning day, and you've obviously seen a lot of the stuff's already live. This is the job that's been in progress for ages. And I did do testing when I laid the cables to start with, just to prove continuity and insulation resistance. I did do all these tests before, but there's been some alterations since then, so that's why I'm doing them again, and this is why I'm documenting them again. So all the wiring is now finished as of today for these different circuits, so that's why I'm recommissioning them. But just to let you know, I did do all the dead tests when I did this originally, so I don't, any comments to say why am I doing them now after I made everything live? That's because there's been some changes and I'm doing them again. I did them all when I first put all this cabling in, so that's the reason why we're doing them now after the circuits have been live for a little while. Okay, so final test of the day on the oven cooker circuit is getting 0.32 against the 4mm circuit, so that's perfectly fine, so we can handle that, and there we go. Oh, there you go. Right then, so that's the commissioning almost complete. You saw on earlier videos that I'd already done the RCBO tests on the lighting and the socket circuits. I've already done those. You saw me in a different video showing you how to do an RCBO on a lighting circuit, so I'll put a link to that video up there. I'm just going to redo the RCBO tests for the oven and hob circuits, and then that is all the testing done. Then I can just finishing up in the loft and the job is finished. So here we are. We've just seen this so many times before, but here we are all set up ready to do the RCD test for the hob circuit. So we are set to 30 milliamp auto. Just going to get going. 2000, that's fine. 2009. Okay, we're going to do the stuff on the board, then we'll come back and see what the readings are. Just sort of show you what happens while we're doing these automatic tests. So this is the RCBO we're testing, this one here. And that should be all the tests completed, so we're going to see. So back here, let's recall the results. So 2000, 2008, 16.8 at times 1, 6.8 at times 5, 16.4 times 5. All those tests have passed, so we're happy with that. Turn that all off and we'll go to the next circuit. So we're plugged in now on the cooker circuit. Don't forget when you're doing an RCD test to power everything on or it won't work. Okay, let's go and check the board again. As you can see, the other RCBO has gone off now. Let's get that on. Okay, and that should be those tests done. Let's go and see what the results are. So we should have 2000s, and we should see an 8, 17.6, 7.6, and 16.8. So again, that's absolutely fine. That's passed, no problem. So that concludes all the commissioning tests for all the circuits that we've been doing. You can see we've got metal studs that have been put in, and we're going to be putting in these adjustable metal brackets between these studs. So I've got this one already bent, so that one's going to go into there, then fold out that way. Onto those, we're going to be fitting double back boxes. So just out of the shop, there's another wall. We're going to be putting a pair of switches on there, and then some unswitched sockets at ground level. Over here, we've got another switch to put in and another socket to put in at the bottom. That's for a dishwasher. Over here, we're going to have a fridge, freezer, and a washing machine. Because we're in metal stud work, we've got to use plastic conduit for additional mechanical protection. So there'll be 20mm conduit going up into the ceiling on a run there. Then the cable will run across the ceiling, across here, and down into this section here, which might just be outshot. We're going to be running 4mm, a new 4mm radial into this end of the kitchen. The far end of the kitchen is on the main house ring. This is, because the wall here is going to have insulation and it's going to be in conduit, there's a lot of derating that's gone on. A 2.5mm cable just won't cut it over here because of the washing machine, the fridge freezer and the dishwasher. They're all running at the same time. We could run the risk of overloading the cable. There's going to be a 4mm cable run back to the consumer board, which is also being replaced, but that's going to be done in a couple of weeks. So we're going to run that 4mm cable over the roof, not over the roof, through the rafters, down to here, and then basically run through here in plastic conduit. We're not going to do a horizontal run, so we're not going to drill holes in these, which is a good thing. We're just going to run them through the ceiling and down. So the first job is we're going to run the 4mm cable from the consumer unit, which is about 10 metres away from where I'm standing. We're going to run that in first, and then we're going to start mounting these brackets to the wall, and then the wall boxes, and that should get us to the first fix stage. It's a couple of day job. We're going to come. The longest part of this job is running that cable across, coming down to these brackets, and then we're going to get the. We'll use a Schneider monitoring system for the switches. I think that'll look really neat and tidy. I think it'll look a nice, neat and tidy job when we're done. It's just a shame no one's going to see it in the end. It will be plasterboarded off. But anyway, so I'm not going to video running the cable over the loft space because that's not really necessary. So we'll come back when I've run the cable and we'll show you how we mount these brackets. Okay, so we finally got the new 4mm cable installed. Now it's come down there. There it goes, all the way down there. So that's in. So we've now got to start working out where we're going to put these metal brackets. And we've got the white conduit to go in. So this switch is going. It's going a MK grid switch arrangement's going there. And then down the bottom will be 2 unswitched plugs. And then the cable, the radio cable is going to come back up there, across there, and if I'll show you, it's going to be coming down here, so there'll be another switch for the dishwasher, and down the bottom there will be a single unswitched plug. So the grid switch over here will be for the washing machine and fridge freezer, which will be down there, and dishwasher behind me. Now, other building work going on behind here. Behind this wall is the bathroom, and new pipe work is going in, so I've got to bear that in mind when I'm doing my work. So what we decided to do is with these is we're going to mount them that way round, 35mm box on there, and then we're going to use these to hold the conduit into place. Probably a really good way of doing that. Sorry about that, the phone went. So just to repeat, what we're going to do, we're going to mount these sliding rails this way round, and we're going to put the 35mm boxes on there. Just drop that on the floor now as well. And we're going to use these saddles on the brackets to hold the conduit in place. It'll make sense when you see it in place. this way we can actually, because these cutouts are off centre, so we can mount this. There's 10mm plasterboard to go on the front. We've got 15mm pipework to go in as well, and then hopefully the 15mm pipework will either go in front of this bracket or behind it, and there'll be plenty of room. There's 70mm of space in this wall cavity to do all this work. So I think that's going to be the best way we do it, and I think all the pipework will go in nice and neat inside. Another reason for using the PVC conduit is obviously that my cabling is going to be less than 50mm from the surface, so it's going to have to be, it has to have extra mechanical protection anyway. Yeah, could I use metal conduit to do it? Well, that's debatable. That's for people in the comments to make. I'm sure there'll be lots of people commenting on this one. Anyway, so now we're going to try and work out the heights of all the different brackets for the brackets to go on. There are going to be 3 in total on this wall, one at the bottom, one there, and one there to hold the conduit in place, and then there's going to be another 3 over here, one at the top, one there, one at the bottom, and then there's going to be extra ones for the water pipe work for the bathroom. So that's what we're doing next. Oops. Get in. There. There you go. 114 is there. That is there. Ooh. And we need. Okay. Whoa. Yeah, brilliant. Love this gadget.
Yeah, we're obviously going to have to reposition that box again, aren't we?
Yes. Just to one side, so I can get the conduit in. I'll probably move it. Probably needs to move over 2 inches this way, and then the conduit could go up.
Yeah, I like that. That's a big improvement on cutting bits of plywood.
Yeah. That's going to be. It's a bit tough, that one. Right, so I'm just going to get that. I'll get the 3rd screw in there, and that should be level. That's right. Once it bites, it's fine. It's only just because the holes in this thing aren't already threaded. So you just maybe if I put them in first.
So they need to be self-tapping screws, don't they?
Yeah. So I might do that with the other ones. I might put them in first to thread them, and then put the boxes on. That's perfectly level, that is now. the screw's not quite in. There we go. Okay, that's in. Right. So, okay, so I will need to get the laser level lined up with that, so I can put the bracket in the right one up there.
Okay.
So yeah, if we move that out of the way, just move it about 2 inches that way.
Let's get flat screwdriver.
Okay, so we've moved that out of the way, and now we're going to mount up the saddle. So I've got the laser level on, make sure we've got that lined up. That's not quite lined up actually. Let's just line that up a bit better. There we go, that's about lined up. So, and let's mark that hole off. So it's that one there. And that's where we're going to put the saddle. Get me a pen, put it away in my pocket, there we go. Right. Actually that is going to be a bit... Right. That'll do the job. Oh! Do it the old manual way. So I'll get that in there. Dead centre. Okay, so that's in place, that'll hold that. There we go. Right, so that's mounted in. Right, okay, so let's get this on. Right, so that's it. Okay, so we know those are all in the right places. I just need to put the conduits in there. Right, so I'll get those measured off and we'll connect up those conduits. Okay, whoops daisy. Let's get that one in place. Get that on there. That out.
So that's basic here, but all the parts are available as the case for haircuts, and that starts assault individually. Another useful accessory is the UJK assembly square. Now this has a number of uses. You can use as a quick reference, as a guide for a track saw.
Okay, that is straight. It's just, it's a bit curved on that bit there. That's okay, it is straight to that point. So, okay, we can live with that. Okay, that's not gonna, that won't work. That's going to be proud of these beams, which is going to foul the plasterwork. So I'm going to take out the spacer saddle here and directly connect that straight to the bracket, I think. Okay, so on this wall we're going to be putting in a single socket at the bottom, single switch and bracket here, just like we did on that wall. So conduit coming down to the switch and then conduit coming down to the socket. Roughly about 114 high here, 450 from the floor, and again we're about 70, the halfway between the two for the bracket. So I'm going to mark those off and then we'll come back. Okay, so we've got all the metal bars in, they're all done, and we've got all the cable now down in the right place. It's junctioned in the loft, so we've got that cable going up. There's a supply cable coming from the consumer board to a wago junction box in the loft. One line then goes over there and one line comes over here. Just makes it easier because it's 4mm cable. Masses of cable coming into the back of these boxes. There won't be enough room, a lot of room in the first place. So we're going to put a single gain switch here, double pole switch, and then there'll be a socket, single socket down here for the dishwasher. So we get those on, and then a bracket out there for the conduit, which we'll put in a second. So we've marked the hole already, so we'll get that screwed on, and then we can go from there. dear. There it is. So that's all the hardware stuff and the cable down. So we just need to put the new consumer board on and liven it all up.
Tremendous.
So that'll just come down. That'll just come down to there. Another 4mm down there, and then worry about that one over there. And then we'll take out the old ring. Sorted.
Brilliant.
So yes, you can put, as I say, we can put that plasterboard on that side. That's not a problem. You're leaving the plasterboard off on this one because you've got pipe work to do, haven't you? Is that right?
Yeah, it's not going to get done for a while, that.
Right. Okay. So we can just carry on with this side,
Yeah.
and then that'll be done. Right. Now the socket fronts are coming tomorrow. I do know that because Screwfix have just confirmed it. See what we can do. Yeah, I don't know. Cool. You see, there it is, the 4mm. You've got two 2.5s going down from the, effectively it's a fuse spur because this switch is a 20 amp fuse spurs. That's the fridge freezer marked up, that's the tumble dryer marked up, and down here the two cables coming out the bottom. Now, whoops, these are the things we're going to be using, which are from MK. So the modular switches, modular plates. I'll take that one out of there because you actually can't get to these screws. So you've got to run the cable into this, fit this up, then fit it into the plate, and then fit it. Whoops! Then fit it to the wall. So we've got that, and somewhere floating around, I've got the new tumble dryer switch, which will go in there. So in there. Now, on this one, my original plan was to get a unswitched double socket. Came up with a problem there though. Those sockets only have one set of connections, so regardless which switch you switch here, both double sockets would go live. So, the solution that I've come up with, if you just bear with me and I'll just grab them, are these. These are from NAP, but they're made by loads of manufacturers. This is a socket module. They've got two of those. There's the other one. There's the faceplate, and those two modules clip into there. They're independently powered, and that will do the job. So what I'll do is I'll label those up to do that. Obviously the other one's not a problem, that's just a single socket. So I'll start getting these wired up. Unfortunately I forgot the battery for my main camera, so I'm using my mobile for this, which is a bit of a shame. But yes, we'll get those done, and then we're going to do and then we'll do the dead tests all the way through. And once we've done that, that comes off the wall. Those two on the ring go back up into the loft, and I will get those sorted out. And we'll come to those later. Right. So basically, here's your socket front. Oh, sorry. There's your front that goes in. Here's your socket. Normal connections on the back, and all that does is it just clips in on the front to the back, like that. Give me a second. It does go in, because I've done it before. I've had it out. There. Okay, that's one. Back, here's the second one. And done. And there it is. Oops, there we go. There we are. And there are the connections on the back. And that just goes straight onto that back box. Like I say, put a couple of labels on the bottom there, and that's the solution. Might not be the most elegant solution for plugs that are visible, but plugs that aren't going to be visible, like we're doing here for these fridge freezers and tumble dryer, they're not going to be seen. I think that's a really neat, really nice solution. Yeah, so we'll get that on, get that all wired up, we'll get that on. Procedure for these, the MK ones. So that's the module you'll get, and you have to buy this separately, and that is what connects onto the back box. And then there's a front that comes on, so that goes on that way onto the socket, onto the back box, and then those two screws are the ones that line up with the front. So those, like I say, those screws go onto the back box, those two screws to the front. That's your module. Now before you can fit the module into here, as I just mentioned, there's where the screws are, and this plate here interferes with those screws. So the best way I can see of doing it is get this fitted up. So it's like a normal fuse spur. So you've got your supply and your load. As you can see, this is an earth, so you've got to get your earth through. There's an earth bar, there's an earth there, an earth on the back box, so you can do all that. So get your cables in first, get them screwed in, and then it clips from the front to the back, just like the other ones I've just shown you. Clips in, same with the one next to it. So this is a 2 module, and you can get 4s as well for double back boxes and so on. So that's how that all goes together. So we'll get that all done, and then we'll show you how it looks. So that's how it looks now that it's on. You can see all the wiring's in there, down there, and it's also got the fly lead from the back box. That's been done. So that screws on onto the front of that. Oh look, that's not good, is it? That says top. Does it really matter? Oh, I'm worried about that. Right, so we'll get that on. I don't think that's going to be a problem, to be honest with you. I know it says top, but that doesn't really matter. So let's get that on, and then we'll see how it looks. So that's how it looks, the finished front. Obviously that front will come off. There we go. That front will come off when the plasterboard comes on, so we'll just need to take that off when that happens, but we don't need to at the moment, so that's fine. That's just not on there properly there. There we go, just now. It's all clipped into place. Yeah. So I think before I go any further today, I think what I'm going to do is I'm going to do the dead tests. I'll get those out of the way and done before I finish carry on. So we've stripped the end of this cable, which is the 4mm cable going to the new radial. So I'm going to connect these up, put the earth and the line together, and then we'll do the continuity test at the other end, and then we'll do the insulation resistance test, and then that just clears those out of the way. I know I should do, there's a test I need to do once I've connected the switches up to make sure that the continuity goes all the way down to the sockets, but we'll do that. But they're not going, the distance of that cable isn't going to really change the readings. It's just mainly to make sure that it all works before I power it all on. So I'm going to do these. These will give me the readings I need. Now I've measured the distance of the cable because I've teed off in the loft. The actual distance to both sockets is exactly the same. So it won't matter which of those two sockets I'll be doing it from. Normally when you do a radial, you do it from the furthest point. But the way I've wired this up, because I've teed it in the loft, the distance to both sockets is exactly the same, so there's no point. It doesn't really matter which I do this test from, it'll be the same. So let's wire this up and then we're going to do the tests. Okay, so I've nailed the leads, and let's see what the reading is. 0.22. Yeah, that should be about right. I'll double check those readings when I go home, but that should be right. As you can see, I'm going to new batteries in this, I think so. Right, so continuity line to earth, that's fine. We don't need to do the line to neutral really. Okay, so as you can see, we've got the fridge freezer and the tumble dryers, those mounted in their bracket, ready to go in. Little problem though, the sockets on the back won't allow two 4mm cables to go in, and I've got to do that because you've got to get power from both these switches, so you need to have a fly lead between the two. So if you bring the main supply cable into here, then you're going to run a fly lead from there to there, so at least one of them will have two 4mm cables in it, and you can't do that. So what I've come up with is this. So the main supply cable will come into this wago here for the line, and the neutral from the supply will come into there. As you can see, I've then connected those neutral into neutral, line to both switches. they bend down quite nicely. Those are the supply cables going on there. Sorry, those are the loads going down there, which are 2.5mm cables. And because I've used a 35mm back box, I'll just put that up against it. As you can see, there is plenty of room for that to work. Normally these are that you're told to use 25mm back boxes on these. If I had done, that would not have worked. So if you come across this problem, if you're running a 4mm radial and you're having to run these switches, get a 35mm back box and you should be able to do that kind of arrangement on the back. Just come through and how we're getting this all wired together, because there's lots of wires in a very small box. I'm glad I've got a 35mm box now. So those are the supplies. That's the 4mm. These are the going down to the sockets. I've labelled them so I know which one's going where. And the massive earthing cables, because of course you've got to earth this plate here and the back box. So see how I've done this. So you've gone to that point there, and then I've done a fly lead up to that one, and then they've all come off that one, then I'm running all those back there somewhere. So now I'm going to try and get these all connected onto the front switches, which I've lost. Right, so those are the switches. As I said, I've done those at the front, so they can go in that way. So I've got to get the supply cables, these two, into these two waygos, and then these load cables go into the bottom of that, and then hopefully this will go plonk into there. Yeah, right. Okay, so after much mucking about with the cabling, we've finally got that in. I thoroughly recommend anyone doing this uses 35mm back boxes and not the 25mm, because you won't have the room. Anyway, so I've connected up the line and CPC in the cable at the other end near the board, and let's just switch off. So let's do that. Okay, so the fridge freezer will be on the left hand side socket. Fridge freezer, fine. I'll turn off the fridge freezer just to make sure. I'll turn on the tumble dryer. Nothing should happen. Yep, so that's good. So let's move the sockets. Do the same test. There we go. Both switches are off. Test. Nothing happening. Tumble dryer switch. Yep. Come back up. And again, same test. Fridge freezer switch. Should do nothing at all. Excellent. So that's all tested and works all the way back. So I'm happy with that. So now we can do the other one. Okay, so this one is a little bit simpler. We've only got one switch to put in here in a single socket, so not anywhere near as many cables to get into this. So we'll run the supply CPC to the back box. I'll then run a fly lead to the bracket, and then I'll connect the load cable CPC to that, and that should give us earth continuity right the way through. Like I say, not as many cables to get on this, so we should be alright with that. Okay, so there we go. So the dishwasher plate in the socket is on. That was reasonably straightforward. So we just need to get the single socket on there, and then we can do the continuity test. Make sure that all works, and then we can deal with the consumer board. So there we go. That's all put into the socket. So I'll just get it on the wall, and then we can go from there. Get it on there and we'll test it. Okay, so here we are, we're at the board now. I could do with tidying it up a bit. I need to check with Fusebox as to whether I can shorten those tails from the RCBOs, because if I can, that will make that neater. But this section point is a bit of a going over. That one there I could do with, doing something with it, just neatening it all up. I think it needs just a good going over. Like I said last week, I was on the clock. So what I'm going to do now is I'm going to get the new radial in, which is going in on this one, So it's that 4mm cable I'm probably going to bring down. I'm probably going to bring down this tube. Yeah, I'll probably bring it down that one, and then get it into this. Because the house is obviously lived in, you know, I really am limited as to how long I can have the power off for. So it's kind of on and off a bit. So we'll do that, and because we've done all the dead tests to the circuit. So I just need to get it in and get it livened up now. Because now people might say, well, why are you livening it up but it's not finished in there? Well, that's the client's is still building on the house. They've got to live in the kitchen, and they need the they're moving a dishwasher in soon. So you know they've got to have it working. It's not like, you know, when you're doing a house that's not occupied, it's fairly easy to do all this. But when you're dealing with a house that is occupied, you have to sort of go with the flow, so to speak. Anyway, we'll get this cable in, which is this one here, which is way too long, so I need to short that down before we do this, and then we'll go from there. So as you can see, I've isolated the ring. We're decommissioning this temporary socket now, so we're not going to do that. So we're going to join these two segments of the ring together, and then we're just going to put them up in the loft, because we have got more work to do here. If I just go around the corner there, we've got that to do yet. So I'm going to leave the length of those cables for the moment, just in case we need the length, and then we'll go from there. So I'll just connect these up and then go from there. But what I'm going to use, that to connect them together. And I know you're going to think, how are you going to do that? With these, the new 221s from Wago, 32 amp, let's bring us up here, 32 amp inline connectors. So those will go into this. This is normally used for joining lighting circuits together. We're going to do this with those. Join those together with that. Okay, so there you go. That's using one of those lighting boxes from Wago, and the new inline connectors, and that's that ring all put back together again. We just need to test it. Okay, so we're going to locate the new fuse box board, probably up about here. I'm going to get rid of that's going. Now, as you can see, the actual cables head up and into the roof space there. Now, I want to try and find a way, if I can. I've got some trunking, some 50 by 50 trunking, and I'm going to see if I can neaten that up a bit. But as you can see, we've got a bit of an overhang there, so I'm not quite sure how to neaten that up just yet. I'm going to have a think about that. But I think there's be a way of making that more neat and tidy, to be honest. Now, I've already labelled up some of these cables already anyway, but I'm going to just double check some of the labelling. Obviously we've got over here is the gas meter, and that's all been, as you can see, it's all earth and stuff anyway. So let's have a look at the board that we're putting in. So here's the fuse box board. It's an 11-way board. It's got a nice spot for an SPD, so we'll put a blank in this side for the MCB for the SPD. So we use one of those. Seen these before. All these are all RCBOs, all in those boxes, so the longer types. So we're going to put those in. There's 7 to go in. We'll do the largest to the smallest. Sorry, the largest to the smallest. We've got some fire retardant grommets which are going in the top. So I'll knock those out. Ooh, there we go. So I'm going to knock out all of those and just put those in. That'll give me lots of space to put the cables in. And then underneath we've got a gland for the incomings there. Little gland for the incomings there, so I'll probably knock that one out as well. So we'll get all this lot prepared first, then I'll label up all the cables and then we can get going from that. Okay, I am just wondering, because the 50-50 trunking I've got, that's not going to work, it's not going to look neat there. So I'm actually thinking I do have some Flexicon spare, quite a bit of it actually. This is 20mm stuff, and that could go, I could put the 2-ring final cables in down through one of those. The lighting cables could go down another one. The 4mm are big. There's 3 of these. There's the other one. They'd have to go down I could put a 32 down. So on the top of the board we've got 32 slots and 20 slots. That's a Flexicon connector in there. I've got flame retardant things in those at the moment, which I've just put in. I am debating the best way to do this, make this a neat job. If I can avoid it, I don't want to run it like that. I want to run it slightly differently if I can, but I don't have any 32mm flexible cable, and I'm not sure if I could get it by tomorrow. I need to think. Right, okay, yeah, we're going to go down the Flexicon route. Managed to locate some 32 Flexicon stuff that will arrive tomorrow, and the glands as well. So we've got more than enough of that, which is the 20mm. That'll be fine for the smaller gauge cables, but the 4mm, which I've got 3 here, they'll go down the 32s. So, and then we've got the earth ones. So the earth ones you can see. So let's go back to the new board. So on the new board, so on the new board, the earth, they're going to go through that one, which is a 20. These two are 32s, so those are going to come out, and I'll put 32 glands in there. These are the 20s. These are from CEF, part of the Flexicon range. So I've got 3 of those, and the Flexicons will go in there to 1, 2, 3 20mm. So plan is 2.5s and 1.5s will go down those, and the 4mm will go down those. I think that'll look quite neat and tidy, and I've also got the clips to put those to the wall. I can't locate the 32mm ones at the moment, but that's not important. I could put the 32 ones on another day. So it looks neat and tidy and workable. It'll be fine. Right, let's finish off getting that board done. Okay, so tail glands in. Got all those at the top ready to go. Like I say, the 32s will come out. This board's actually going in tomorrow. I'm just doing the setup work today. This is actually scheduled to go in tomorrow. So we're trying to get all this work done that we don't have to worry about. So you can see the main bus bar can come out, which is great. The derail, sorry, not the bus bar, the derail can come right out, so you've got all that room in there. I love this thing. Put the derail in. So what I'm going to do, because this is a blank ready for an SPD, what I'm going to do is I'm going to use another one of the blanks, which are these, and I'm going to put that blank in there, and then that's ready then for the MCB that will be used for the SPD to connect all together at that end of the board. Then we'll do the 32s, the 16 and the rest of 6s all along here, and we should have 3 spares at the end. So I'll clip that one in, and that's done. And then I'm not going to clip anything else in, there's no point at the moment. And then I'll work out how we're going to dress this thing ready for tomorrow. Okay, so I just wanted to make sure this all went in nicely. So this is how the board is going to look. Obviously all these will come back out when I'm putting it on the wall and putting it all together. As you see, so we've got the blank for an SPD, blank for the MCB for the SPD, then a line of 7 RCBOs running 4 32s to a 16 to a 6 and a 6, 3 blanks, so we've got 11 ways in total. At the top, 3 Flexicon 20mm glands. Those 32s are going to come out, and that one at the 20mm on the end is going to be the earth, and tail gland all in. So all of these will go up to the neutral bars, then with the cables come in through here, you've got the line and neutral going into the top of each of these, and the earth wiring going up to there. So plenty of room to dress this really nice and neatly. Okay, so good morning. So today we're going to be taking this off the wall, getting it replaced with a new board. We're going to put the board further up. So we'll put this on time lapse while we get this off the wall, and then we'll go from there. Right, okay, so here we go. So you can see the new fuse box board is on the wall. Just about in the right place. As you get it a little bit higher up. People might notice this, and it has been pointed out. Yes, this is a problem. This is not 150mm away from this gas pipe, but as you can see, it isn't straight either. So the owner, the client, is actually going to be getting the gas board in to deal with this and shift it over. There's nowhere else that board can go, so that's going to have to go. But anyway, so what I've managed to do is the tails are coming up here and out of the way, so that they are actually further away than they were with the original board. Anyway, next thing I'm going to do is I'm going to properly measure up those flexible cables at the top here, get them the right length, get that done. We'll get the tail, we'll get the gland in, and we'll get those tails up the inside, and then we'll mount the din rail. I'm probably going to reconnect the earth as one of the first jobs, actually, to be fair. I'll not reconnect over all the earths. Get those done first, and then that's done. I don't have to worry about it. And then we'll go from there. Actually, I might do that first. Anyway, you'll see what I'm doing. Right. Okay, with some fun and games, we've finally got the cables into the new board. This was a bit of a bugger. That line, this is off by the way, the line screw was misthreaded, so I had to fix that. That was a bit of a problem. Anyway, so it's all in. I will attach these, once we're all finished, I'll attach these to the wall, make it all neat. So we've got all these into here. These will all be neatened up later. I'm going to be back in over the next few days anyway, because we've still got, this is the new radial that needs to go in, but I'll put that in today. So in order, so coming down this conduit, we've got the hob and the cooker. Coming down this conduit, we've got the ring and the ring spur, which is going to the garage. That'll be dealt with another time. Down this one, we've got the immersion. And down this one we've got two of the lighting circuits, and that one we've got a third lighting circuit. Some point in the future they can be amalgamated and they'll all be on the same one, or we might junction them further up, but for today we're not going to do that anyway. So basically what we're going to do is we're going to start putting in all the RCBOs, 32 amps along here, and then going to the 16 and then the 60s. We've really got those 3 times. So there's 4 32s to go, and one isn't being connected at the moment. And then we'll go on from there. So, bit of donkey work now to put all this lot in now. So, we'll get on with it. Oh, nearly a faux pas. The client is actually wanting an SPD in this, that's why that blank is there. But there needs to be a blank this side of the main switch, because the SPDs for fuse box actually have a separate MCB. I do know there are some SPDs that have the MCB actually in them, but fuse box isn't one of them. So let me okay, so like I said, we're going to number these, so we're going to put all the 32s first. So we're going to put this one, we're going to run from 1 to 13. So this one will be, you could argue, should I put that in position 2 because of this? I think so. Let's put it in position 2. 2 Newton meters. I need to alter this, I think. No, it's on 2, that's fine. So let's get this into position 2. Probably put this on fast forward now. Okay, so as you see, we're getting there with it. Like I say, this I'm going to tidy up that at another time. This is not looking too bad, as you can see in the back. Yeah, not great. I've shoved everything along one because I've got that 32 is for the radial that we're putting in, which is this one, and this cable is probably going to come down that conduit. So that's the hob cooker, I think. This one is going to be the ring. So we've got the ring on and the garage, which is these 3 cables here, and then we're into the final 3, which are the lights. Okay, so we're getting there. That's the ring and the garage socket. Oh no, we're going to do the inversion. Right. Okay, we are there. In previous videos you've probably seen me do the RCD testing from the sockets. Well, as you can probably know some of these circuits, they're on lighting circuits. You've seen me do it from a pendant fitting, but one of these is on the boiler. You can't do that, there's no socket there to test from. So we're going to do the test from here. As you can see, it's all off at the moment, but obviously I'm going to have to turn this on in a second. So we're going to do this from the board, and I'll show you how we're going to do it. We're going to connect the earth lead of the tester to the earth board, and we're going to connect the neutral and the line into the top of the RCBOs. Now these are fuse box Type A RCBOs. Now there's an ongoing debate on how many tests you should do on a Type A. I'm going to be doing 10 tests. I'm going to be doing the AC tests, and then I'm going to follow them up with the A tests. There's an argument that you don't need to do the Type A tests because they've been done by the manufacturer. Other people say that the AC tests aren't valid when you're doing a Type A, because you're not testing the Type A. There's lots of opinions on this at the moment. My opinion is it's all very well that these have been tested by the manufacturer, but that's under laboratory conditions. They're not in real world conditions. So how do you know that this still works after it's been delivered to you? You don't. So I feel you've still got to do these 10 tests of the 5, so the half, 2 halves, 2 ones, 2 5s, which is 6. I don't know why they say it's 10. And then on the Type A's. So I'm going to switch my tester from Type AC to Type A when I'm doing these tests. I'm still going to record the highest 1 times and the highest 5 times. I know that there's some forms now that you only need to record just the highest reading of the 1 and the 5. The NAPIC forms still require you to do both, so I will be recording both. So I'm going to get my tester, we're going to get it set up. I'm going to zoom in so you can see what's going on. I'm not going to do any talking now, so hopefully we'll see the I'll zoom it in so we can see what readings are coming up on there, and we'll take it from there. Obviously I'm going to have to turn it on, but I'll turn it on only one of these at a time. Okay, I'll have to hold up the tester because it's not going to actually show otherwise, I'm afraid. So I'll just stick that there. So we're going to have to get the power on to start with. So we've got the power on to start with. So we're going to do each one of these in turn. Okay, so we're going to get the power on to the isolator, power on to the main switch, power on to the first circuit. So we get the tester, and we're going to set the tester to 30 auto. Okay, set to my AC, we'll just make sure of that. Make sure you get them around the right way, obviously. Okay, put it on blue, and there we're on the earth. We're getting voltage. We're set to 330mm auto AC. It's passed that first one. Past the second. Past the third at 39.2, that's times 1. Past the second at times 1 at 30.4. Past the third one at times 5. And 9.2 as well. So that is the 5 tests. I was wrong earlier on. So the 5 tests are it does the half times once, then does the 1 times twice and the 5 times twice. So that's the 5 tests. Take those off there. And if I want to recall it, just hold that up there, do the recall. So it's passed 39.2, 30.4, 19.2, 9.2. There we go. So now we're going to do the Type A tests on the radial. Let's change this to Type A. Let's turn it on. Neutral and line. So let's get the Type A readings. Pass at the half. Pass at the half. At 1 times we've got 39.2. 28.8 for the second 1 times. 19.2 for the first 5 times. And 9.2 for the second 5 times. So that's that one completely done. So now we can move on to, like I say, the hob is the next one. Yep, hob is the next one. So we'll turn that circuit on. Switch my tester back to AC. Neutral first, and then line. Oh, I'm not getting. There we go. And off we go. Half pass at 2000, greater than 2000. Half again passed. $33.6 for the first 1 times. 30 for the second 1 times. 13.6 for the 5 times. 13. And 9.2 for the second 5 times. Take those off. Right, we'll change it. Oh, it hurts your hands, this. Change it to A type. Oh, hang on. Yeah, don't forget to turn it on. And off we go again. Type A this time. 2000, greater than 2000, I'd say. Hang on a second. It is actually, I'll be honest, it's not easy doing this and keeping the probes actually connected. So I can do it 2-handed this time. So, but that's fine. 33.6 for the first time. 23.6 for the second times 1. 13.6 for the first 5 times. 6 for the second 5 times. So take those probes off. Crikey. Right, so that's the hob done. Now we move on to the cooker circuit. That's all the tests. One final test to do. Pressing the test button. And that's done. That's all done. So there you go. Like I said, there's a debate on how many of these tests you should do on Type A RCDs and RCBOs. I'll probably do a separate video on why the debate rages as to whether you should do just 5 times or 10 times testing. You know, do you have to test the Type A side of things when it's been done by the manufacturer and all this sort of stuff? I've done all 10. That's the way I've been taught to do it, so that's the way I'm going to do it. And as I mentioned earlier, because of NAPIT's forms still require you to do the 1 times and the 5 times highest readings, I'll be taking those readings and making them note in the certificate. That completes this job now. I hope a lot of it's been informative. There's been some unique solutions to some various problems that I've encountered. I may sort of take those out, maybe put some video shorts on those, but they'll be in the chapters, I expect, anyway. But yes, this job's all done. This will all be tidied up on another time. As I say, this coming backwards and forwards to this job, there's lots of projects to do over the next sort of 12 months. But I hope it's been informative, and we will we will see you on the next one.